Cryptocurrency is a form of digital currency designed to operate without the control of governments or traditional financial institutions. The concept first gained traction in 2008 when a white paper appeared on Bitcoin.org, authored under the name of Satoshi Nakamoto. To this day, no one knows whether this name represents a single person or even a group of developers. The underlying technology of cryptocurrency is called blockchain, a secure digital ledger that records transactions across a distributed network. This innovation introduced a decentralized financial system designed for transparency, resistant to tampering, and capable of transcending national borders. This vision led to the first and most recognized cryptocurrency, Bitcoin. Over time, the movement expanded, giving rise to thousands of alternative coins known as altcoins. While Bitcoin remains the leader, these digital assets represent a new way to exchange value globally. Cryptocurrencies, or tokens, are pieces of digital code representing ownership of a digital asset with value. They operate within a network that allows participants to send and receive payments without relying on banks or governments. At the core of each coin's blockchain is a decentralized digital ledger that records every transaction and adds new blocks to the chain. Instead of relying on a single central server, copies of this ledger are distributed across thousands of computers or nodes, forming a linked structure. Any attempt to alter a record would require changing all copies simultaneously, which is nearly impossible. This near impossibility comes from how blockchain works. Each block contains verified transaction data, a timestamp, and a cryptographic hash of the previous block, forming an unbreakable chain. A potential attacker would need to recalculate every block and update thousands of nodes at once, while overcoming consensus mechanisms like proof of work or proof of stake that demand enormous computing power or stake ownership. Let's break down how proof of work and proof of stake compare in blockchain verification. In proof of work, or POW, systems, new coins enter circulation through mining, a process where computers compete to solve cryptographic puzzles. The miner that solves the puzzle first adds a verified block of transactions to the blockchain, which is then broadcast to all nodes for validation and synchronization. This mechanism secures the network while introducing new coins. Miners receive token rewards for contributing computing power. To maintain scarcity, mining algorithms gradually increase difficulty, slowing coin creation over time and helping preserve value. However, proof of work comes with high energy consumption and relatively slow transaction speeds, averaging about 5 transactions per second for Bitcoin. Popular cryptocurrencies using proof of work include Bitcoin, Litecoin, and Dogecoin. Proof of stake, or POS, selects validators based on the amount of cryptocurrency they lock as collateral, eliminating the need for energy-intensive computations. Scarcity in proof-of-stake systems is maintained through fixed supply limits or controlled issuance, and by staking, which temporarily removes coins from circulation and reduces available supply. This method is highly energy efficient compared to proof of work and supports faster transaction speeds, often hundreds or even thousands per second. Proof of stake promotes scalability and decentralization, making it the preferred choice for newer platforms such as Cardano and Solana. Ethereum, the second largest cryptocurrency, transitioned to proof of stake in 2022, improving consistency and accelerating block production. Blockchain is highly secure thanks to its decentralized design and cryptographic links, but weaknesses often appear in connected systems. Most breaches have targeted exchanges or exploited flaws in smart contracts, not the blockchain itself. Incidents like these have led to stronger code audits, improved security practices, and stricter regulations to protect users and reduce future risks. Blockchain has changed the way we view currency and computing, introducing a decentralized model that has the potential to upend traditional systems. In the next chapter, we'll explore how crypto fits into everyday life, real-world blockchain applications, adoption by financial institutions, and what government regulation means for the future.